Okay, at this point in our calculus journey, we have almost learned every derivative rule you could imagine. The last rules that we need to learn are the ways that you take the derivative of exponential and logarithmic functions. So the good news is we're almost done. Few more rules to learn. Let's talk about the derivative of any exponential function. So in this case, a is just a number. So an example here would be like 2 to the x power. The reason that this is an exponential function is because the x is in the exponent. When you see that, you cannot just use the power rule. You can't just say, I'm going to drop the x and subtract 1. It doesn't work that way. So, to take this derivative, here's the rule. We say that the derivative of this would be itself. So the derivative of a to the u power is a to the u power times the natural log of a, so the base. Plus, because u doesn't necessarily have to be an x, it could be a 2x, a 3x, an x squared plus 7, we have to then use the chain rule and take the derivative of the actual power of the function. Now, one specific exponential function that comes up a lot is e to the something. E to the something is one of the most common bases that we're going to be using. So if I were to take the derivative of this, I would do e to the u times the natural log of e times du dx. But we know that the natural log of e is just 1. I'm just using this same rule that I can use for any base to take the derivative of this specific base. If the natural log of e is 1, then this formula actually simplifies. We usually just write that e to the u would be e to the u times du dx. Basically, the derivative of e to the something is e to the something times the derivative of the something. Now, let's talk about logarithms. So if you ever see a logarithm and it asks you to take the derivative, the rule is this: 1 over the stuff. Whatever the stuff is, you put it on the bottom, times the natural log of the base. So a, whatever the little number is, times the derivative of the stuff. That's the chain rule part of it. Now, one common logarithm that comes up a lot is natural log. ln is really a log with a base of e. It's just a shortcut way of writing that. So if I apply this same formula, I would have 1 over u times the natural log of e times du dx. Since we just reviewed that the natural log of e is actually just 1, we usually just say that the derivative of natural log is 1 over the stuff times the derivative of the stuff. Here's the basic idea. These rules work all the time. But since base e stuff comes up so often, we have shortcut rules that we memorize just for base e stuff. So let's look at some examples. Here it says f of x is e to the x. Find the derivative. The derivative of e to the stuff is e to the stuff times the derivative of the stuff. So the derivative here would be e to the x times the derivative of x would just be 1. So your answer would just be that the derivative of e to the x is e to the x. That's it. He is his own derivative. Whew. Now if we look at a different base, like the base 3, the derivative here would be 3 to the x times the natural log of the base times the derivative of the stuff, which is a 1, because the derivative of x would just be 1. So your final answer would be 3 to the x times the natural log of 3. Let's look at ln. We usually just say that the derivative of ln is 1 over the stuff times the derivative of the stuff, which in this case would just be a 1. So your answer would just be 1 over x. And the derivative of a logarithm would be 1 over the stuff times the natural log of the base times the derivative of the stuff, which in this case would just be a 1. So your final answer will be 1 over x times the natural log of the base, which is 4. Now those are what I would call, ooh, you can't really see what I wrote there. I apologize. This camera really just doesn't capture the page very well. Let me allow you to copy that down for a second. Pause the video if you need to. Okay. Those 4 examples are what I would consider some very basic examples because there isn't really chain rule involved. All of the derivatives of the inside stuff here were just 1 because it was just 3 to the x. Here, where we have e to the 2x, chain rule is going to come into play. So if we take the derivative here, the derivative of e to the something is just e to the something. But then we're going to need to take the derivative of the something. In this case, that would be a 2. So we would say that our final answer is 2e to the 2x. If we're taking the derivative of g, 4 to the something, the derivative would just be 4 to the something times the natural log of 4 times the derivative of the something, which in this case would be a 2. So if I just put the 2 at the beginning because it's a coefficient, I would have 2 times 4 to the 2x plus 1 times the natural log of 4. Now, derivative of ln would just be 1 over the stuff. Times the derivative of the stuff, which in this problem would be a 4. So if I write the 4 on the top, I get 4 over 4x plus 5 is my derivative. Next, the derivative of a regular logarithm. Now this one's a little bit tricky because you can't see the base. If you can't see the base, it's a 10. We have 1 over the stuff times the natural log of the base times 2. And I'm not like being crazy here. If you can't see a base, it's automatically a 10. So I would just write the 2 on the top, and I would have 2x minus 1 times the natural log of 10 is my derivative. Now, a couple more, a little bit more challenging examples. So for number 9, we're taking the derivative of something with an e in it. So, y prime would be, the derivative of e would just be e to the same stuff that you started with. But then you need to multiply by the derivative of the stuff. So I would have 1 plus 2x. And since I can't really simplify this, I'm done. For number 10, the derivative of 2 to the something would be 2 to the something times the natural log of the base, which is 2. And the derivative of 3 is 0. So you're done. The derivative of log base 2 of 3 to the sine of x would be 1 over 3 to the sine of x power times the natural log of 2. Then I need to take the derivative of the 3 to the sine of x part, which would be 3 to the sine of x times the natural log of 3. And then I need to take the derivative of sine, which would be cosine. This is just chain rule on steroids. So we did the original, we did the log part, then the derivative of the next inside part is here, and the derivative of the sine part is here. It's just layers and layers and layers. So to make this look a little bit prettier, I'm going to write 3 to the sine of x times the natural log of 3 times cosine of x all on the top, and 3 to the sine of x times the natural log of 2 on the bottom. Now when I do that, I notice that the sine of x, the 3 to the sine of x parts cancel. So I get the natural log of 3 times cosine of x over the natural log of 2. And that is the answer. Again, let's make it a little bit more complicated. So these problems are going to require us to do product rule, quotient rule, chain rule, all kinds of crazy things. For this first part, I'm going to need product rule because e to the something is one function and 5x to the fourth minus 4 is another function. So to do product rule, I would copy the first function, e to the 4x squared, take the derivative of the second function, which is 20x to the third. Plus, then I would copy the second function, 5x to the fourth minus 4, take the derivative of the first function. The derivative of e to the something is e to the something times the derivative of the something, which is 8x. Now, if you think way back to when we were learning to simplify really complicated derivatives, we said, since this guy has an e to the 4x squared and this guy has an e to the 4x squared, we can factor that out. Now, what's left would be 20x to the third plus 5x to the fourth minus 4 times 8x. So to simplify this, I'm going to distribute the 8x. When I do that, I'm going to copy down the e to the 4x squared, copy down the 20x cubed, and when I distribute, I get 40x to the fifth minus 32x. So my last step is just to write this in descending order. So I get 40x to the fifth plus 20x cubed minus 32x, and I'm done. Like I said, a little bit more complicated. There's some product rule going on here. Not too bad. We've definitely done harder problems than that before, so I know you guys can do this. All right, now for number 2, I'm going to need to use quotient rule. So I've got the high and I've got the low. The rule goes low, d high, minus high, d low. The derivative of natural log would be 1 over the stuff times the derivative of the stuff. And low squared goes down below. Now we're going to simplify. So, the fourth power and the fifth power cancel and make a 1. The 2 and the 10 cancel and make a 5. Which means I get 4x, I'm going to pull out to the beginning, times the natural log of 2x to the fifth minus 5 over x times 2x squared plus 3 all over the natural log of 2x to the fifth squared. In order to avoid having this x in the denominator here, I'm just going to multiply through by an x to make that cancel. So when I distribute an x to the first term, the second term, and the bottom, here's what I get. I get 4x squared natural log of 2x to the fifth minus 5 times 2x squared plus 3 all over natural log of 2x to the fifth squared. If I wanted to, I could take this minus 5 and distribute it, but because I see right away there aren't really going to be any like terms here, I'm just going to stop there because distributing isn't going to give me any like terms, which means it's not really going to simplify anything for me. And I'm done. Okay, that's good. Last derivative rules. That's it. So we're done. Thanks.